Welcome everyone to a Kuta worksheet tutorial. We are rationalizing the denominator, square roots. You're going to see this in Algebra 1, Geometry, Algebra 2. So let's go ahead and introduce the basics of this with number 1. Here we have 5 times the square root of 9 over the square root of 16, so that's in the denominator. This one's a little bit more simple, not in the typical case, because these two roots can be reduced to an integer. So we would rewrite this as 5 times 3, the square root of 9 is 3, and then the square root of 16 is 4. Actually, I want to rewrite that as like this to show you that those are the numbers. Okay, so then we simplify this and we get 15 over 4. They don't have any common factors, nothing to reduce it by, so we're going to circle that as our answer. Okay, moving on to number 2. Very similar, that there's not a lot we can do with this one. Here we have 16. That is going to be reduced to 4 in the denominator. Okay, and then we have in the numerator 2 radical 3. Now, what you can do is anytime you have integers on the outside, you can't do this with radical. Well, actually, you can. I'll get to that in a second. But you can reduce your numbers in the top and bottom just like as before. 2 goes into 2 one time, 2 goes into 4 2 times. So it's 1 radical 3 over 2. You don't need to write the 1. It becomes square root of 3 over 2, and that's our answer. Okay, now getting into a little bit more complicated, this is what you are really here for. There's a couple different ways to do these problems. I'm going to show you first the way that you can approach every problem, and then another way to approach this problem that only works out when you can identify that you have a common term in the top and bottom that you can cancel. Okay, so first thing, if you have a big square root, that's not a perfect square root, so if you're looking here, for example, square root of 8, we can simplify that. Okay, so I'm going to do an arrow here, and I'm going to rewrite 5 radical 2 over, now square root of 8, anytime I'm doing radicals like this, I think the easiest way to understand it is factor tree. I talk about this in simplifying square roots if you want to check out one of those videos. But the premise of that is we're looking for pair prime factors. Okay, so as I'm factoring, I always like to put the prime factor on the left, and it just so happens there's one on the right here at the end, but I put prime factors on the left, and then I'm going to circle pairs of prime factors. Okay, why do I do that? Well, I don't want to draw the arrow just yet, because then I can rewrite this as square root of 2 times 2, I pair them up, times radical 2. This guy's by himself, so he's going to stay in the house alone. You have to have a date to leave the house. That becomes square root of 4 times square root of 2. Square root of 4, we know that's the whole point in finding a pair. So this is going to be 2 radical 2. So I'm going to put this in the denominator, okay, as 2 radical 2. Now, from here, normally, this is the approach for every time. Anytime we have a radical 2 or a radical in the denominator, to get rid of it, we multiply by that same radical to the top and bottom. Why do we do that? Well, we do that because this value here is equal to 1. If you have a number divided by itself, it's equal to 1. If you multiply by 1, it doesn't change the value. 5 times 1 is still 5. We just change the look of it after we multiply. Let me explain. Well, first we have in the bottom, we're going to have that 2. And then we're going to have radical 2 times radical 2. This is what I was talking about. We chose that for a reason because that's the same thing as radical 4, which is equal to 2. Anytime you multiply a radical times itself, you just get what's underneath the radical. You get rid of the radical. Okay, and then on the top, what do we get? Well, we get 5 times, and then again, 2, because we have radical 2 times radical 2. That's equal to 2. So what do we have here? We have 10 in the top, 4 in the bottom. That can be reduced to 5 over 2. Now, there was a shortcut in this one, and this is not always the case. That's why I wanted to show you that first way first. If we have 5 radical 2 over 2 radical 2, we can recognize that we have it's the same term in the top and bottom with multiplication. So this just simplifies and cross out. You get 5 over 2 for that one. Okay, let's get a little harder now. I'm going to skip 4. I'm going to go to one that's a little bit more difficult. How about number 5? So number 5 here, we have 3 radical 15 and then 2 radical 80. Let's go ahead and break this down. So we have radical 80 here that we're going to have to factor. It's a big radical and it's not a perfect square. If it was 81, then it'd be 9, but it's not. Now you're going to see that 15, you can't break down any further. It doesn't have any pairs. Those are both prime numbers. There's no perfect square within 15. Square root of 15 is as simplified as it gets. But not 80. Okay, prime factors on the left, there's 2, and that's 40. Divide by prime number again, 2, that's 20. Divide by prime number again, 2, that's 10. 2, that's 5. Okay, circle pairs. There's 1, 2. There's another 2. So I know essentially, okay, square root of 80 is going to be square root of 4 times square root of 4. And then the square root of 5 gets left by himself inside the house. Okay, have to have a date to leave the house. Square root of 4, 2 times radical 5. That's 4 radical 5. Okay, so essentially what happens is this 1, 2 leaves the house. 1, 2 leaves the house. That's what that means anytime you circle a pair. Okay, don't forget to write, though, don't forget to write this 2. That 2 stays. So 2, and then we have that 4 times radical 5. That was our radical 80 right there. Okay, so it got simplified to 4 radical 5. That was our radical 80. Okay, in the top, 3 radical 15. Okay, what do we do from here? Well, we have 3 radical 15 over 8 radical 5. Now, there's 2 ways to solve this. I'm going to show you the first way, which is the guaranteed way. This always works. Okay, we recognize that we have this 5 in the bottom. So we're going to multiply by radical 5 over radical 5. You cannot have a radical in the denominator. So we get 8 times 5 in the bottom. Okay, I'm going to change that to purple, actually. 8 times 5 in the bottom, and then 3 times, what is that, radical, I think that's 75. Radical 75 in the top. So this is unfortunate because we have to rationalize this, simplify this radical 75. So we divide it by 5, and you get, what's that? 75 divided by 5. 15, what am I doing? 15. And we get 5, 3. I just multiplied that. Okay, so here, my point is, now we see we have a pair of 5s, so this becomes 5, and then radical 3 stays inside the house. So this gets rewritten as 3 times 5 times radical 3 over 8 times 5. That's 15 radical 3 over 40. You simplify, dividing both by 5, and you get 3 radical 3 over 8. Or you could have just recognized that you can cancel the 5s here, and we get 3 radical 3 over 8 that way. Okay. Now let me go back and show you an easier way to do this. Okay, so let me go back here. An easier way. Over 8 radical 5. Okay, because we have this 3 over 8, okay, but this square root of 15 over square root of 5, this can be rewritten as square root of 15 over 5. Okay, you can do that with radicals. You can put them back in the same house if they both have the same radical, and that just becomes square root of 3. So then this becomes square root of 3. Well, that becomes 3 radical 3 over 8, and you can see that is another way to do this problem. You're like, whoa, that's way easier. But it doesn't always work out that way. That's why I wanted to show you the first way, where you multiply by the radical over the radical first, so you understand how to do that, but sometimes you can look for that also. Let's see if there's any harder ones over here. Okay, for example, this one's a good one. Here we have 5 over 5, so we're going to just cancel the 5s first. Anytime you can see that, just get rid of it. And then we have radical 3. Can't have the radical 3 in the denominator, so what do we have to do? We have to multiply by radical 3 over radical 3. There's no other way around it. That's why I wanted to show you this method first. This, of course, is equal to 1. We're not going to change the value. We're just going to change the look. And we get radical 3 over radical 3 times radical 3 equals 3. And there's our answer. Okay, a lot of these ones are the same way. Let's do 14, and then we're going to do one with a variable right after this. Can't simplify anything. Actually we can. This can be reduced to 2, so let's rewrite this problem. 5 times 2 over radical 3. That's 10 over radical 3. We need to multiply by radical 3 to the top and bottom to rationalize that bottom. And we get 3, 10 radical 3, nothing else to simplify, and we're done. Okay, let's get to a variable. Anytime you have a squared term, you're looking for squared terms here. And you're going to have to know laws of exponents to do this. So for my geometry class, I'm not going to emphasize this. But in case you're watching, Anytime you have a squared and you take the square root, it's going to be just without the square. Okay. If you have m to the fourth, though, and you take the square root of that, then it's going to be m to the second. Okay. The power, when you take the square root of something, essentially you're dividing it by 2 with the exponent. Okay. So if you have something like m cubed and you take the square root, this can be rewritten as m squared times, let me make this in purple so you, a little bit more emphasis. No, pink. How about pink? Okay. So anytime we have m to the cubed, or to the third power, we can rewrite that as the square root of m squared times m, because m squared times m equals m cubed. So we can rewrite that as so right here. Okay. Now, we can simplify this. That's m, but we can't simplify that, so it gets left inside the radical. Okay, it's essentially doing the factor tree method, where we do m squared, m, and then we look for a pair. And so one pair can leave the house, and one has to stay home, radical m. Okay, so that's an FYI on that. So let's go ahead and take a look at this problem. We have square root of 3 times the square root of m squared over 3 times radical 2 times, I'm separating it all out just so it looks a little bit easier. Okay, these ones, so that's an m squared that we can reduce as m, and then we have radical 3 in the top still, over 3 needs to stay in the bottom for now. I'm going to simplify this. We already kind of broke this down. This is going to be m radical m. So I have times m radical m, but don't forget about the square root of 2. Okay, so now I have, let me rewrite this in blue, change it up. M radical 3 over 3m square root of 2m. Okay, we see this in the bottom. We can't have it. We need to multiply by radical 2m over radical 2m to get rid of it, to simplify it, to rationalize the denominator. So we get m radical, and then we're going to multiply underneath the radicals to get 6m. Okay, so anytime we have underneath the radicals, they can get multiplied together to give you your underneath the radicals, so 6m. This is over 3m times, it undoes the radical when you multiply them by each other, 2m. So this gives us m radical 6m over 6m squared. The last step is we can cancel one of the m's. This is definitely a tougher problem for my geometry students, but for algebra 2 students, you guys are going to have a cakewalk with this. Square root of 6m over 6m, and there's your final answer. Hope you guys found this tutorial helpful. Make sure to watch more videos on this, especially simplifying radicals and square roots, and I hope to see you next time on Wes Explains Best.